Hey there, science fans! Have you ever wondered why things float? Why does a giant ship stay afloat while a tiny pebble sinks? The answer lies in a fascinating scientific principle discovered by a brilliant guy named Archimedes over 2,000 years ago. Archimedes' principle basically says that when you put something in water, it gets pushed up by a force. This force is called buoyancy. And guess what? This upward force is equal to the weight of the water that the object pushes aside. So if the object is heavier than the water it displaces, it sinks. But if it's lighter, it floats. Simple, right? Now let's dive deeper into this amazing principle and see how it works in the real world. Get ready for some exciting science adventures. Imagine yourself relaxing in a nice, warm bath. As you slide deeper into the water, you notice the water level rising. That's because your body is taking up space and pushing the water out of the way. Now imagine that you could weigh the water that your body pushed aside. The weight of that water is equal to the buoyant force acting on your body. That's Archimedes' principle in a nutshell. Buoyancy is all about the balance between the weight of an object and the weight of the water it displaces. Think of a beach ball. It's filled with air, making it lighter than the water it pushes aside. The result? It floats. Archimedes' principle isn't just about bathtubs and beach balls. It explains how massive ships, some weighing thousands of tons, can float across the ocean. Ships are designed with a special shape called a hull. The hull is hollow and filled with air, just like our beach ball. This makes the ship much lighter than a solid chunk of steel, the same size. Submarines, on the other hand, can travel both above and below the water's surface. They have special tanks called ballast tanks. When these tanks are filled with air, the submarine is buoyant and floats. But when the tanks are filled with water, the submarine becomes heavier than the water it displaces, causing it to sink. Legend has it that King Hero II of Syracuse once asked Archimedes to solve a royal mystery. The king had given a goldsmith a lump of pure gold to make him a crown, but the king suspected that the goldsmith had cheated him by mixing in some silver. Archimedes puzzled over the problem. He knew that gold was denser than silver, meaning that a certain weight of gold takes up less space than the same weight of silver. But how could he measure the volume of the irregularly shaped crown without melting it down? One day, as Archimedes was taking a bath, he noticed the water level rising as he lowered himself into the tub. "Eureka!" he cried, realizing he had found the answer. He immersed the crown and a piece of pure gold of equal weight in water, carefully measuring the amount of water each displaced. The crown displaced more water than the gold, proving that it was indeed mixed with a less dense metal. The goldsmith's deception was exposed. Section 5. Who was Archimedes? A genius from ancient Greece. Archimedes, who lived from 287 to 212 BC, was a true Renaissance man, centuries before the Renaissance. He wasn't just a brilliant physicist, but also a mathematician, astronomer, engineer, and inventor. Born in Syracuse, a Greek city-state in Sicily, Archimedes is considered one of the greatest mathematicians of ancient history. He made groundbreaking discoveries in geometry, calculus, and mechanics, and his inventions like the Archimedes screw, a device for raising water, were centuries ahead of their time. Section 6. Archimedes' legacy, from ancient baths to modern science. Archimedes' principle might have been discovered in a bathtub over 2,000 years ago, but its impact on science and technology is still felt today. It's a fundamental principle in fluid mechanics, helping us understand everything from the design of ships and submarines to the behavior of hot air balloons and even the density of planets. Section 7. Why should we care? The importance of Archimedes' principle. You might be thinking, this Archimedes guy sounds pretty smart, but why should I care about his principle? Well, understanding buoyancy is not just for scientists and engineers. It helps us understand the world around us, from why things float to how fluids behave. It's also essential for many everyday applications. For instance, knowing about buoyancy helps us design safer and more efficient boats, submarines, and even aircraft. It also plays a role in fields like meteorology, oceanography, and geology. Section 8. Float your boat. Fun experiments to try at home. Want to see Archimedes' principle in action for yourself? Try these fun experiments at home. First, the floating orange experiment. Take an orange and put it in a bowl of water. It floats. Now peel the orange and put it back in the water. Does it still float? Why or why not? Second, the clay boat challenge. Get some modeling clay and try to make it float in a sink full of water. Can you shape the clay so that it displaces enough water to support its weight? And third, the Cartesian diver. This classic experiment uses a dropper and a plastic bottle to demonstrate buoyancy and air pressure. You can find instructions online. Section 9. Keep exploring. The science of floating continues. So the next time you see a boat floating on a lake or a balloon soaring through the air, remember Archimedes and his incredible principle. Keep asking questions, keep experimenting, and keep exploring the amazing world of science. Here's a question to keep you pondering. If you could weigh the Earth, could you calculate its density using Archimedes' principle? Stay curious, science fans.